Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is matrices. What you're going to learn today is how to perform scalar multiplication of a matrix. So let's begin. So after completing the very lesson today, my dear student will be able to multiply a matrix by a given scalar number. This is what I hope you'll be able to do after completing the very lesson today. My dear student, in your favorite segment of the lesson, Mercy is fun. Today, I'll give you another interesting number, 1729. This number is so interesting, so amazing. I will explain what is interesting about this very number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us first take the rule. It is this rule that will guide us what to do in order to perform scalar multiplication of matrix. Rule number 1 is says multiply each and every element of the matrix by the given scalar. When you do that, you now have a new matrix, and that new matrix will now have elements equals to the products of those corresponding elements in your original matrix by the scalar. So your new matrix will now have elements inside it, and those elements, if you take each one, you can see that that element will now be product of the corresponding element in your original matrix by the given scalar. We are going to take examples how we can make use of these two guidelines and find the scalar multiplication of matrix. So let us move and take examples. Example number 1, it says given this matrix B, and these are the entries inside this matrix B. You have 2, 1, and minus 1 in the first row, 3, 2, and 4 in the second row. And the question asked here is to compute 2B. 2B simply means the 2 times the matrix B. So in this case, this number 2 is a scalar number. Solution to this very problem. What we do first is to have this to 2B. 2B means the 2 times the matrix B. So let me just copy down my matrix B and with the 2 outside it. So this is my 2 times the matrix B, and this is matrix B. So each and every element here will now be multiplied by this number 2. Let me do that. So I'm going to have 2 times 2. Then next, this one is also going to be multiplied by this 2. So I'm going to have 1 times 2. This also element will now be multiplied by the scalar number outside. So look at it. So I'm going to have minus 1 times 2. This will now be the element in the first row of my new matrix. Then if I move to the second row, I'm going to take this also, each and every element here times the scalar number. So let me do that. So 3 times 2. Then 2 times this 2 outside also. Next is 4 times 2. So I'm going to do this multiplication so that I will now have exactly the entries in my new matrix. So 2 times 2, look at it. So this 2 times this 2 will give me result 4. And next I'm going to have 1 times 2. That will give me result 2. And the next I'm going to have minus 1 times 2. That will be minus 2. And the next I'm going to have 3 times 2. That will give me 6. And next I'm going to have 2 times this 2. That will give me 4. And the last 4 times 2. That will give me this entry 8. So if you look at these entries, each one is now nothing but a product of the entry in the corresponding position in the original matrix by this scalar. So each of this entry you now take is just a product of the corresponding entries by those by the scalar number. Let me just move and take another example. Example number 2, it says given that this matrix F has this entries 2, minus 1, and 3 in the first row, 4, 0, 9 in the second row. The question asked is to compute minus 2 over 3F. That is the matrix F multiplied by the scalar number minus 2 over 3. Solution to this, what we will now do first is to copy down the given task. That task is to find what will now be minus 2 over 3. F is this very matrix. So this will now copy down the matrix F and have the scalar minus 2 over 3 outside it. And this will now be each of these entries inside the matrix F multiplied by this scalar number minus 2 over 3. Let me just do that. So I'll now open my large square bracket so that I can now do this multiplication inside. So I'm going to take minus 2 over 3 times this element 2. Let me do that. So I'm going to take this element minus 1 multiplied by the scalar 2 over 3, minus 2 over 3. Let me just write it and take the next one, which is the 3 times the scalar minus 2 over 3. That will give me the element in the first row, third column. I'll continue. So I'll now move to the second row. 4 times minus 2 over 3. I'm going to have something like this. Next here, to get the element in this very position, second row, second column, I'll take 0 times minus 2 over 3. And the last is 9 times minus 2 over 3. This is what I'm going to have. So after multiplication, I'm now going to have 2 times minus 2 over 3. Look at it. That will give me minus 4 over 3. That is 2 times this 2 will give you 4. I'll continue. So I'll move to the next one. The next one is minus 1 times minus 2 over 3. That will give you positive 2 over 3. Look at it. The next one is 3 times minus 2 over 3. You can see this 3, you cancel this 3, you'll be left with minus 2. Look at it. So I'll move to the second row. 4 times minus the 2 over 3. Look, let's see it. This will give you minus 8 over 3. And next one, 0 times minus 2 over 3, of course, is going to be 0 because anything times 0, the result will be 0. And the last will be 9 times minus 2 over 3. You can see 3 in the 9 will be 3. 3 times this minus 2 will give you minus 6. So this will now be the result of or the new matrix that is equals to this minus 2 over 3f. Let's just take one more example. Example number 3 says compute what will now be 2a minus 3b if you have matrix A to be equals to 1 and minus 3 in the first row, 2 in the second row, 3 and 4 in the third row, and another matrix B with this entries 2 in the first row, 3 minus 2 in the second row, and 1 in the third row. These are the two matrices A and B, and the question asked is to find what will be 2A minus 3B. So solution to this very problem, what we do is to get what is the 2A and what is 3B, and those two new matrices will now subtract them. So 2A minus 3B, what I'm going to do now is to substitute each of those matrices, that is matrix A and matrix B. So I'm going to have something like this 2 times matrix A. I have replaced this A by this matrix, then minus your subtraction there. Then the matrix 3B. So you now have 3 times the matrix B. I have replaced this B by this matrix. Look at it. So you now perform the scalar multiplication before this subtraction. Let me do that. So I'm going to have, after this scalar multiplication, this to 2 times the first matrix, you are going to have 2 minus 6 in the first row, 4 in the second row, 6, 8 in the third row. How I obtain that is 2 times this one gives you 2, 2 times minus 3 gives you minus 6, 2 times 2 gives you 4, 2 times 2 gives you 4, 2 times 3 gives you 6, and 2 times 4 gives you this very 8. Then I will also do the scalar multiplication. That is 3 times every entry inside here. So I'm going to have something like 6 in the first row, 9 minus 6 in the second row, 3 in the third row. If you did correctly, this is what you're going to have. So what I'm going to do next is to perform this subtraction. So let me do that. So you're going to have here 2, this entry in the first matrix minus the corresponding entry in the second matrix. So 2 minus 6, that will give answer minus 4. Then I'll move this minus 6 minus the corresponding entry in the second matrix. So you have minus 6, minus 6. That will give a result to minus 12. Look at it. I'll continue. So I'll take the next one, which is 4 minus 9. 9 is the corresponding entry in the second matrix. So 4 minus 9, that will give answer minus 5. I'll write it here. I'll continue. So next is 4 minus minus 6. This minus minus will now change it to plus. So you have in the end 4 plus 6. That will give answer 10. I'll write it here. I'll continue. So next is this number 6 minus it is corresponding entry in the second matrix. So 6 minus 3. That will give answer 3. And the last is 8 minus the 3. That will give result 5. So this is the matrix that is equals to this to 2a minus the 3b. This is the end of this very lesson, my dear student. I hope you find it resourceable. Let me just move to the last segment, Mercy's Fun. I explain what is interested about the number 1729. This number 1729 is very interesting in such that it can be expressed as product of two primes. And those two primes numbers are reverse of each other. This is what is really interesting about this number 1729. So let's just find out and see. So 1729, like I have said, can be expressed as product of two primes. This is not just a special. Many numbers can be expressed as product of two primes. But what is very, very special with this number, those prime numbers are reverse of each other, meaning are mirrors of each other. So let's see. 1729 can be expressed as 19 multiplied by 91. Both of these numbers are prime. And looking at 19 and 91, you can see exactly they are reverse of each other. So multiply 19 by 91 will give you this number back 1729. This is very, very interesting with this number. Thank you for your attention. We'll see more of this and other things in mathematics in our subsequent lessons.